This is a recorded revision lecture for PHY250 Relativity, for which you have an optional question in the paper that you're taking on Saturday, and the very best of luck. So I thought I'd cover some material here which is of relevance for revision and is interesting and hopefully will help you prepare for the course. The first thing I thought I'd cover isn't actually the first thing that we taught in the lectures. It's the connection between the various formulae that we have for energy and momentum, because this is something that people get confused with sometimes. So the first formula that we have is the relationship between total energy E, momentum P, and rest mass m0. And that's the energy momentum mass relation, which looks like this. The square of the total energy is the sum of the squares of the momentum magnitude times c all squared, and the rest mass times c squared all squared. Sometimes you see this written p squared c squared plus m naught squared c to the fourth. So that's the first equation relating these three quantities. Now there are also expressions which are often written down for the energy and the momentum in terms of the rest mass and beta and gamma, where, well, of course you'll recall that beta is just the ratio of the particle velocity to the observer who's measuring these quantities to c, the speed of light in a vacuum, and gamma is 1 over, don't forget the 1 over, the square root of 1 minus beta squared. Actually, that's another trap that people fall into with these equations. They often forget to square the beta. So if you start with beta and go to gamma using this formula, do remember to square the beta. That's very important. Anyway, that was a slight digression. In terms of these quantities, the total energy E can also be written as gamma times m naught c squared. Okay? And the momentum magnitude P can be written as gamma m naught times the particle velocity. Okay? So the question is, are these expressions consistent with the top one? And I'll show you that they are. So the first thing I'm going to do is to write this equation for the momentum like this. I'm going to write it as gamma times m naught c times v over c. Right? All I've done is introduced a c top and bottom. So c over c is 1, so I've multiplied by 1, so all's good. Then I'm going to multiply the whole equation by another c, so I get pc equals gamma m naught c squared times v over c, but v over c is just beta, so I end up with pc equals beta gamma m naught c squared. That leads to some interesting things, by the way. You can see that this expression doesn't look so different than the expression for the total energy. In fact, we can take their ratio. So if we take PC and divide it by E, then you end up with, well, PC is beta gamma m naught c squared, and E is just gamma m naught c squared. And you're led to kind of an interesting result, because everything except the beta cancels. So you're left with that the ratio of the momentum of the particle times the speed of light to the total energy is just beta, the ratio of the velocity of the particle to the speed of light. Does this simple result make sense? Well, yes, it does. If you have a photon, or a light particle, a light beam, the constituents of photons are massless. Constituent photons are massless, so they must move at the speed of light. And so you know that for a photon, V equals C. So beta equals 1. And so for a photon, or for light, E equals Cp. The magnitude of the momentum times the speed of light equals the total energy. That's only true for a photon, it's not true for a particle. Okay. So the next thing is, having shown this interesting result, we can relate it to some other results that we already know. So let me do a little board cleaning here. I'll leave the top one up. Alright. I'm going to leave that one up as well. I guess I'm going to write E equals gamma m naught c squared. And we've just learned that beta equals the ratio of the momentum magnitude times c over the energy. We also know, because we have E equals gamma mc squared, we also know that gamma, the other quantity which we use quite a lot, that equals the total energy over m naught c squared. So these two expressions provide relationships between the quantities beta and gamma, which are related to velocity, and the quantities momentum p and energy E, which are related to dynamics. Okay? Finally, let's show that these expressions give rise to the energy momentum mass relation. So if we take the square of Pc and add it to the square of mc squared, we're going to write p squared c squared as beta squared gamma squared m naught c squared squared, and m naught c squared squared is just m naught c squared. So the right hand side of this equation, the right hand side of the energy momentum mass relation, is equal to beta squared gamma squared m naught c squared all squared plus what's already there, m naught c squared all squared. And clean the board a little bit more. So factoring out the square of m naught c squared, we end up with 1 plus beta squared gamma squared. But that, in the brackets, is just 1 plus beta squared over 1 minus beta squared, because gamma squared equals 1 over 1 minus beta squared. And that's because gamma is equal to 1 over the square root of 1 minus beta squared. So this equation in the brackets can be manipulated. It can be turned into, putting everything over a common denominator of 1 minus beta squared, it can be turned into 1 minus beta squared plus beta squared, all over 1 minus beta squared. Then the beta squareds cancel, and the thing in brackets is just 1 over 1 minus beta squared, which is the same thing as gamma squared. So this quantity here is gamma squared m naught c squared all squared. Okay? But that's just the square of the total energy. So I've just shown you that p squared c squared plus mc squared all squared, if you substitute in the expression for p in terms of beta and gamma and m and c squared, that sum of these two things on the right equals the total energy squared. So the energy momentum mass relation is consistent with the expressions for E and P in terms of beta, gamma and the rest mass m naught. And that's very useful.